All right, today we're going to talk about the architecture of future power. But we're not talking about a new power grid on Earth. We're talking about an infrastructure that spans the entire solar system. It's a real-world plan called HELIOS-MESH, and it's designed to completely redefine what's possible, all while being built silently, almost invisibly, right above our heads.
So, to really get where we're going, we first have to understand where we are right now. You see, the most critical layer of our modern civilization, the thing that makes everything tick, it isn't on the ground anymore. It's in orbit. Our communications, our navigation, our sense of time, it all runs on this fragile shell of satellites that we've just come to completely take for granted. And this quote right here, it just nails the whole idea. Think about it. You don't think about GPS or your satellite connection any more than you think about the power station when you flip on a light switch. That invisibility, that's actually a sign of incredible success. But it's also a huge vulnerability because we've become totally dependent on something we don't even see anymore.
And that leads to a pretty huge question, right? Our dependence on Earth's orbit, that was just step one. So what happens when the next network isn't just built around the Earth, but spans the entire solar system? An infrastructure built so far away, its construction would be almost completely silent to us down here. Now, this isn't just some sci-fi daydream. This is where we get into the real nuts and bolts of an actual proposal called HELIOS-MESH. And this isn't some vague idea. It's a very tangible, concrete blueprint designed to be the backbone for a future solar system economy. So what is it exactly? Well, at its core, HELIOS-MESH is a network of really advanced spacecraft. But the most important part of that definition, the key phrase, is self-sustaining. The whole idea here is independence, to finally break that constant reliance on getting support, commands, and most importantly, fuel from Earth. And this just shows you how different these Helios nodes are from the satellites we have today. I mean, think about it, a design life of over 20 years. How is that even possible? Well, it's because of things like in-space refueling. This isn't just about making things last longer. It's a fundamental shift. The entire goal is to be completely self-sufficient. Okay, so a plan this ambitious obviously hinges on some pretty out-there technology, stuff that really does sound like science fiction. But it's actually made possible by 4 key breakthroughs, and some of them are a lot closer to reality than you might think. First up, the engine. It's called magnetohydrodynamic propulsion, or MHD. I know, it's a mouthful. The easiest way to think about it is this. It's a rocket engine with 0 moving parts. Seriously, instead of complex pumps and turbines, it uses incredibly powerful electromagnetic fields to just shoot out superheated gas. And no moving parts means extreme reliability, which is absolutely what you need for a 20-year mission. Next, you need power. Once you get out past Mars, solar panels become, well, pretty useless. The solution here is a thorium molten salt micro-reactor. These things are unbelievably safe. They physically can't melt down, and, get this, they can actually breed more fuel than they consume. This gives a node a power source for decades, totally independent of the sun. Third breakthrough. How do you know where you are? GPS obviously doesn't work in deep space. The answer is something called quantum navigation. It's amazing. By using lasers to cool atoms down to almost absolute zero, these sensors can measure their own movement with incredible precision. It's basically an unjammable, self-contained GPS system that's perfect for a spacecraft operating millions of miles from home. And look, this isn't all just theory. We can ground this in what's called technology readiness levels, or TRLs. The special radiation-hardened computing needed, that's basically ready to go, low risk. The quantum navigation, already being demonstrated. The really big challenges, the high-risk items, are, you guessed it, the propulsion system and getting that reactor ready for space. The path forward is there, but the risk is definitely real. Now this next part, this is arguably the most revolutionary piece of the entire puzzle. To actually have a 20-plus year life, you need fuel. And launching it all from Earth is just impossible. It's what engineers call the tyranny of the rocket equation. So the solution is to live off the land. It's a concept called In-Situ Resource Utilization, or ISRU. The fuel for those MHD engines is helium, and the plan to get it is pretty wild. The near-term goal is to actually mine it from the soil on the moon, the regolith, and the technology for that is already being demonstrated on the ground. But the long-term vision, we're talking after 2040, is way more ambitious, harvesting helium directly from the atmosphere of Uranus. Yeah, you heard me right. But just to give you a sense of the scale of this challenge, especially on the moon,
Get this. To get just 1 single gram of a valuable type of helium, you have to process over 150 tons of lunar soil. That's the weight of a blue whale. For 1 gram. It is a monumental engineering challenge. But if you can overcome that challenge, what you get is this beautiful, self-sustaining loop. You harvest the helium from the moon, or a planet, you process it right there in space, and then you use it as propellant in those super high-efficiency engines. This cycle is what truly breaks our chains to Earth and enables a permanent infrastructure. So, we've covered the what and the how. Let's zoom back out now to the most important question of all. Why? Why build any of this? And the answer? Well, it has some pretty profound implications for the future of, well, everything. This quote, it comes directly from the HELIOS-MESH technical brief, and it really says it all. This isn't just about science or exploration anymore. It's about building the fundamental roads, the ports, and the power stations of a brand new economy. And the critical point is this: whoever builds this network effectively gets to set the rules for that future. And please, don't mistake this for some distant, far-off dream. There's a concrete plan for the next decade. The foundation is being laid right now, with testing of the navigation and computing systems. By the early 2030s, the plan is to be demonstrating fuel production on the moon and deploying the first operational nodes out to Mars. This future is literally being built as we speak. Which brings us right back to where we started and leaves us with this final critical thought. We began with this idea of invisible infrastructure here on Earth. HELIOS-MESH is the ultimate evolution of that idea, an immensely powerful system being built silently, far from the public eye. So the question we're all left with is, when the very architecture of power becomes this vast and this invisible, who do you trust to build it?